All right, welcome to video 2, which is way better than video 1. Don't tell video 1 or the guy that made it. I'm still stuck here with a green shirt, and here we go. We're going to be evaluating functions here, and I think a lot of people have a pretty good foundation for this, but there's some tricky things that we can do with this evaluation. So let's dive headfirst into it. So I'm going to give you two functions. We're going to evaluate some stuff. Let's call f of x the function 3x squared plus 5, and g of x the function 3 minus x. All right, so first things first, what is f of 2? So you just find the function, okay, f. That's this function up top. Forget about g. We don't care about g. Just f. And x is no longer x. X is now replaced with 2. Right? Not f of x equals blank. It's f of 2. All we do is just replace the x with 2. So this becomes 3 times 2 squared plus 5. And you can type this into your calculator or evaluate it normally. And you'll get 3 times 4 plus 5, 12 plus 5, 17. All right. And that's all there is to it. You need to incorporate more terrible jokes into these videos. Let's look again. F of negative 3. You're going to say, this is the same, Jason, but this one has a warning. Okay. So watch out for this. Again, you just replace the x's with the value, negative 3. You get negative 3 squared plus 5. But please, 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 if you are typing this into your calculator, have parentheses around the negative 3. Right? I'm going to make a little note over here. Negative 3 squared is not the same as negative 3 squared. If you look at the audio transcript for this video, it will seem very suspicious. But with the parentheses, they make a difference. Because what is order of operations? Right? Please excuse my dear Aunt Sally or something like that. Parentheses first. Well, there's nothing to do inside the parentheses. Exponent. That says 3 squared is 9. Whereas this is negative 3 times negative 3 is positive 9. Okay, so please watch out for that. Include your parentheses when you're using your calculator. And again, you're going to get 27 plus 5 or 32. You can plug that into your calculator and get that. Just make sure that you plug it in correctly. Okay? All right, now let's make things a little bit more interesting. What about g of a? This is not a number anymore, but you do it the exact same way. G of a, you just plug in a for x. So again, now we're looking at this function, right? G of x. Just replace the x with a. And we get 3 minus a. That's it. Okay. Part D. G of a plus 1. A little bit more complicated. And there's a trick. But it's the same idea. Find your g of x function, but replace the x with a plus 1. So we get 3 minus the whole thing that we're plugging in. We have to subtract, right? We're subtracting all of x. And here, the x that we're subtracting is a plus 1. So you do need parentheses right here. Right? This is not going to be 3 minus a plus 1 because now you're not subtracting the whole input, right? Our input here is a plus 1. And our function tells us to subtract the entire input. So watch out for that. Okay. And again, I'm not going to require you to simplify. I'm going to accept that. But if I do state, which is unlikely but possible, if I do state that I want you to simplify, you distribute that negative 3 minus a minus 1. 3 minus 1 is 2. You get 2 minus a. I would also accept that. All right. Part E, and this can be even messier, right? It could be, I don't know, a squared plus 25 minus water balloon. I don't know, minus b, whatever, right? This input can be as messy as we want it to be. As messy as I want it to be, and as way messier than you want it to be, probably. But the idea is still the same. You just look at the function, 3 minus x, and replace the x with whatever your new input is. A squared plus 25 minus water balloon. I don't know, minus b. Okay, and that's it. And again, I will accept this as a final answer, but you could also distribute and collect like terms if you wanted. Okay. Now here's something that's really good, going to really be important later. So watch out for this. That's supposed to be a star. Use your imagination. Okay, this is not art class. Good thing too, otherwise I would not have a job. G of x plus h. Remember, I'm going to rewrite this so we have it to refer to. G of x we said was 3 minus x. This is kind of confusing because there's an x in here as well. The idea is you just look at your input. Our input is x plus h. And all you do is plug that in, replace the x with whatever your input is. Even though it's kind of confusing, we have x's in both places, it's okay. It's 3 minus our input. Our input is x plus h. Okay. Do one more. See, you have x squared plus 3. No, I'm done with g. F. Again, I'll copy this down so you can see it. F of x was 3x squared plus 5. So you look at your input. Our input is x squared plus 3. And everywhere that there's an x over here, we replace with that input. So it's 3 times the input squared plus 5, right? That's our function. 3 times the input squared plus 5. The difference is that our input's more complicated here. Our input is x squared plus 3. This is going to be very, very important later on in this chapter, okay? I'm doing a little bit extra in this little video. I was going to ask for any questions. I'm recording a video, so if you have questions, email me or ask me on Slack, because I'm probably not going to hear them here. Hopefully not. If I ask for questions and I hear something outside my window or something, I'll be a little weirded out. All right, so let's do a little bit more with functions. All right, a little bit more with functions. Example, I lost, oops, sorry, webcam, or document camera, it's not a webcam. Example 3, I think, maybe. It's example 3 now, like it or not. So for f of x, same functions, 3x squared plus 5, and g of x, 3 minus x. Solve. Part A. F of x equals 5. Now this looks a little similar, but a little different. It's going to be kind of the same. We're not plugging in 5 for x here, right? X is not 5, right? This is not the same as what is f of 5, right? That's the x. We don't know the x this time. I'm giving you the y. Okay? When is this function, when is the y value equal to 5? Well, the only way to do this is just to replace. F of x equals 3x squared plus 5. If two things in math are equal, that means they are the same in any single way that you can think of. Okay? So if f of x equals that, well, then you just go and you plug it in. F of x is 3x squared plus 5. Well, if they're the same, I'm going to write 3x squared plus 5 instead of f of x. Right? These are the same. So this, I just wrote the same thing twice. Your eyes might tell you they look different, but nope, these are exactly the same thing because f is exactly that. And now you just solve this equation, okay? And you've solved quadratic equations before using in 2.5, yes, 2.5. So we subtract 5 from both sides. We're going to get 3x squared equals 0. We can divide both sides by 3. We get x squared equals 0. Take the square root. X is plus or minus the square root of 0, which is just plus or minus 0. X is only equal to 0 here. Okay? Part B. Do part B over here. Save the trees. G of x. Solve g of x equals 2. And again, g of x is just 3 minus x. That's what g of x is. They are the same thing, identical in every single way. So say, well, if g of x equals 2, that means 3 minus x has to be 2. Because these two things are the same. And now you just solve this. Subtract 3 from both sides. You get negative x is negative 1. And multiply both sides by a -1, or divide both sides by a -1. That works too. You're going to get x is +1 for this one. Okay? That's how do these ones, and there's one more. Okay? Example 3, 4, whatever. Example 4, why not? I'm not even going to write this down. Yes, I am. So in this one, we're actually going to look at the textbook. All right, this way I don't have to grab it. What if we do this with a graph? These are the ones that are usually pretty tricky for people. Okay? So we have a function graphed right here. Evaluate f of 4. So there's no function, there's no equation to plug in 4 for x. But remember that this 4 is your x. Oh my goodness. 4 is indeed your x. So you just look at the graph and say, where is x equal to 4? You trace them, let's see, where is x equal to 4? There's 4, there's 4. When x is 4, what is the corresponding value of y? So you search up. Nope, there's nothing up there. Search down and find that corresponding y value. That corresponding y value is going to be -3. So then what we say is we say, okay, all right, find f of 4. 4 is our x. We're trying to find that corresponding y value. So we say f of 4 equals -3, just like so. Similarly, right, if I asked you to find what is f of -3, you'd say, okay, -3 is our x. We need to find y. When x is -3, what is our y value? We go back. X is -3. Look up or down to find the y value. All right, the y value here is 4. We'd say f of -3 is just 4. Finally, solve f of x equals to +1. And watch out here. There may be multiple solutions. Okay, so let's look at the graph. This time, right, we don't know x. We're given the y value and we need to find the x value, right? F of x. We don't know what x is. It doesn't tell us what x is. This time it gave us the y value. So when y is 1, what is x? So we kind of go backwards this time. When y is 1, that's up here, and look left and right to see the value where the graph is. And this time when we look left and right, we get 2. right. We get 2 things here. This is when x is -6 and when x is 0. Both have that y value. We'll have 2 answers here. X is -6 and 0. Do one more. Solve f of x equals 4. Again, we don't know the x, but we do know our y value. When is the y value equal to 4? Find y equals 4. That's up here. And look right and left for where the graph touches. And here it only touches once, right? Only one x value for y to be 4. And that x value will be -3. All right. And this shouldn't be surprising, right? Because we just showed up here, right? That when x is -3, y is 4. So when y is 4, x is -3. Right? There is that correlation here. That's going to come into play at the end of the section when we talk about, at the end of the chapter, when we talk about inverse function, which is good stuff. Okay. And that's video 2, I think. Video something.